Ladies and gentlemen, I present you the wiggle. Now this looks very simple, but underneath the hood, like all simple things, it is quite the opposite. So I have a viewer discretion or a warning for you that I'm about to show you how the sausage is made. Welcome to Voidlog Index 9. This is a series where I share the business and development process of building a billion-dollar unicorn company called VoidPet. Today we're starting in Figma. Here we have the pain sprite, and here is the pain sprite number 2. And we basically want this guy to oscillate into this guy back and forth in a smooth motion. But before I get ahead of myself, how does this guy come to be? And how does this guy come to be? Well, this guy's a little bit harder because you kind of just have to draw him. But after you draw him, if I just scooch him over, there we go. You'll notice that this is made up of several different points. If I just go like this, I go like this, I go like this, a couple times, you basically get frame 2 of pain. And so once you have 2 frames of pain, we can proceed. We export everything as SVGs, and the notation we use is the name of the emotion, aka abandonment or pain, the stage, so this is stage 1, and then whether it's frame 0 or frame 1 of the animation, and that's it. We only have 2 frames for the little wiggle. I made this script called import pets, which reads in all the SVGs, and then it converts them to JSON using this function I have right here to parse the SVG and grab every path inside of it. The output is this thing called path map layers, which is a giant file, like literally giant, because it's every SVG of every pet, and it breaks down each path and the props that are passed to it, and it's, as you can see, just the SVG path. Let's start with the simple case. I just want to render the pet. Doesn't need to animate. How does that work? Well, I have this static layer component where all it takes is the JSON blob that I want to render, and it says if it's a circle, we render a circle. If it's an ellipse, we show an ellipse. Otherwise, it's a path. And those are basically all the different shapes to render all of these guys. There's one other thing with linear gradients, so we also need to render the defs for gradients and radial gradients. But for the most part, it's if statements mapping to the React Native SVG components. Now this is a very roundabout way to render an SVG, but if we break it down between paths, we can also animate those individual paths. Pet Sprite is the top level component where the animation starts. So we use a library called reanimated for the animation, and we keep track of where we are in the animation with this progress variable here. If we're at 0, we show frame 0, and if we're at 1, we show frame 1. And if we're at 0.5, we show something between those 2 frames. Now we actually show a bunch of different frames in between this, and we calculate it based on the duration that we want the animation to last for. Some pets are slower, some pets are faster, and then we slice it up where each frame is shown for 30 milliseconds. Now you'll notice, why do I cut this into more than 2, is because things get really choppy if you don't do that. So let me just show you. If we only show 2 frames, like we just go back and forth between frame 0 and frame 1, it gets like really clunky. Like that's not smooth. That's not a cutting edge wiggle. You know what I'm talking about? So this particular pane actually probably has tons of different frames. So let's see how many frames are rendered in the current amount of time. So the pane animation is sliced into 7 frames, whereas Lust is sliced into 67 frames. Actually, I had no idea that was the case. Wow, look at that little wiggle. Good job, buddy. I'm just really curious for science what happens if I set this to like 10 frames for Lust, how it would look. Yeah, it's just not as good. See how it's just like gets a little clunky? Let's see, like 20. So the 67 frames actually makes it look pretty smooth. Remember that giant JSON object with all the paths? This lovely guy. We look up the pet that we want to animate, and then we render each individual path as its own component. I call it animate layer. If we click into that, you'll notice we have some conditions. If we're not animating, we keep it static. Otherwise, we go into this animated layer function. The magic part of this is the interpolate path function. This is coming from the D3 interpolate path library. And what it does is it takes 2 paths, our first frame, our second frame, and then we can pass in any, I call it step, but any number between 0 and 1, so 0.3, 0.9, and it will spit out a SVG path in between, or what the interpolation of that would be. So what the heck did I just say? What does that even mean? Well, imagine I have this path here, M99, blah, 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 right? And we have this path here, M106, blah, 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 blah. What it does is it takes those two paths. This is not really what happens, but it's roughly what happens. Is it's like, hey, look at this number. And look at this number here. Whoa. If we add those two numbers together, 106 plus 99, and we divide it by 2, and we get 102.75, and that is what the SVG would render for this position. And it does that for every single path in the SVG. This one's simple, it just does it for these two. There's also other properties we have to interpolate. That's what this stuff is doing here. So sometimes there's a CX or a CY, which is like positions and sizes, circles, and whatnot. And for that, I'm using this function called lerp. Very simple, little formula. You put your X, Y in your range, and then where are you in the progress, and it does its magic, interpolates. So all this magic is wrapped in a use memo. So what that means is, since I'm looping, I decided to remember what all the frames are, save them, and make sure we don't recompute on the fly every single time. And I just store all the different frames and what they're going to be. And then I just pass it into this use animated props function, which is a reanimated thing, where you'll notice the progress of the animation. I figure out where we are in the animation, and I render that frame. And it just keeps looping over and over like that and rendering this in-between frame every single time. Or said another way, all the animation is really doing is just changing this string value a bunch of different times per second. And it's doing it for every single path. And for Lust, it slices this up into 67 different pieces, and it changes this path 67 different times. And there's what? 11, probably 10 paths, so 10 times 67. There's a total of 670 different strings I'm storing when just rendering this little animation. Another cool thing that I do is I synchronize the pet wiggle with the item. So you'll notice that I just put a little mushroom hat and a collar on this pane, and you'll notice it wiggles and it stays on the head in the exact motion. So the way that works is we keep the progress of the animation for the pet, but we also pass this, scroll down here, into the pet items, neck and head. And so all that's happening here is same kind of mumbo jumbo as we interpolate between the progress value, and we specify the X and Y value of the hat to match where that pet is going to be. We have another giant JSON file where we store the starting X and ending X position for the items on the pet, also the Y, and occasionally the scale and rotation changes, as well as the pet's doing its wiggle, and the item needs to synchronize with that. Well, there you have it. That is how the wiggle is made. It is working quite well in a lot of different scenarios. It's very easy to make two different sprites of the pet and pop them in on the design-wise in Figma. Now, if we spawn a whole bunch of pets, it will deteriorate. Let me just do that real quick. It depends on the device, but around 20 pets is when things get pretty bad. iOS is much better than Android, so maybe 15, 10 pets is when Android starts crapping out. But we didn't really need 10 pets on the screen or 20 pets on the screen at a time anyway, so we were okay with this. I have tried a few things optimization-wise. I gave SVGO a chance because all you guys recommend in the comments. I'm actually using this in some other places, but I have not done it for pets yet. Unfortunately, it does break the interpolator, at least the path one. So I'm either going to have to go look into that, and I haven't done that yet, but that's potentially going to happen in the future. Otherwise, the only way to make this faster, I think, is just switching to images and doing some kind of Lottie thing. Some people are recommending that. And so that might potentially happen in the future if we run into issues with this or need to render just more intense pets. But as of right now, 99% of the time it works great. Lastly, I did try React Native Skia. A few people mentioned this to me because you can render SVG paths in it and it's supposed to be really fast. I gave it a try this week. It was cool and it worked and I was able to get things to animate, but it did end up just being slower than rendering stuff with React Native SVG and the stuff that I was already doing. So kind of just threw that in the trash can.